Thank you so much for being a part of CSA Agentic AI Security Summit 2026. I am so happy to be here presenting to you. Thank you so much for the opportunity. I'm going to jump right into it, and I'll do my introductions a little bit later. This is a mouse. Well, it's not a real mouse because it's just a picture of a mouse. Hopefully you don't have a mouse right in front of you, and if you do, I hope you like mice. And this is a mouse. Well, it's a picture of a mouse. Well, it's a representation of a mouse. It's a little more abstracted than the first one. And this is a mouse. If you see all the background characters, such as the dodo and Alice, you might recognize it as the mouse with the sad long tail from Alice in Wonderland, one of my favorite books. It's not quite the same as the other mice, though. We can all agree it's taking on certain traits. And this is a mouse. One, it's public domain, and that makes it really, really fun to use. But two, it is the only mouse I have shown you so far that for some reason we believe can drive a steamboat. Now, the reason we believe it can drive a steamboat is the concept of anthropomorphism. When we anthropomorphize something, we assign it human traits, human attributes. Even though we know that it itself is not a human, we treat it like a human. We can't help but do this. This is in our nature. Humans always will assign human characteristics to non-human things. We can't help it. That's just how our brains work. Now, in this case, we anthropomorphize a mouse to represent, well, a fun cartoon. And it's not scary. It's something fun to do. And there's all sorts of psychological things I could talk about with this, but I would like to suggest that that same effect has happened with our computers, with our workloads, with our servers. We've gone through this process in computer science and in enterprise IT of going from knowing a physical real thing called a server to abstracted ideas. And now we've truly anthropomorphized the workload because it's probabilistic. I believe this represents a wonderful moment in time, though. And there's some things we can glean from the way we've started treating our workloads as if they were people. And we can apply the lessons that we're applying now in security to all of our workloads based on the directives we're now implementing around identity and access management for our agents. I'm Dwayne McDaniel. I live in Chicago, Illinois, and I see my entire mission in the world is to help people figure stuff out. I'm currently the principal developer advocate at GitGuardian. They'll come up a little bit in this talk, but not too much. You can find me on LinkedIn, and I'd love to connect with you there. I'll say a little bit about GitGuardian toward the end of this talk, but just know that we are secrets visibility, helping people solve the non-human identity security crisis going on out there. To set the stage, I'm going to give a very, very short too short version of the history of DevOps, but it does need to be said to set the stage for everything I'm going to talk about in the second half of today. In the beginning, there was only one machine. If you were lucky, there was one machine per company, and it wasn't connected to anything. In order to guard that machine, the security mechanisms were literally lock the door, put a guard out front, and stop people from interfering. The CIA triad originates from there. Confidentiality, no one can get in the room unless, well, they're supposed to have a key or the guard lets them in. Integrity, they can't mess with the machine if they're not physically in the room. And availability, the machine should run and keep running if no one messes with it. That's really where this idea of security really originates, is this picture. We'll fast forward in time quite a bit, and now there are 12 computers we hooked together through the ARPANET. And in order to do security for these systems and stop students from wasting computer time, we put username and passwords in place. So now we can track the identity of the user via the fact that they had to know their password and username to get into the system. This worked pretty good for humans for a long time. Back in those days, if we put something into production, it just needed to run, and we hired someone to sit there and make sure it worked. That was operations. This was the era of pets. All our computers, all of our servers, all of the mechanisms that delivered IT infrastructure needed to be kept alive, the same way you would keep a pet alive, patching, loving, care. Then computers got smaller, and there became a lot more of them. They would fit on your desktop, and you could do all sorts of neat things like run web servers. One day someone said, wait a minute, this wall between developers and operations is causing problems. It's slowing us down. I know, we'll put them together and we'll let the developers run operations and operations also become developers. And we called it DevOps. And this is a wonderful thing. And we got so much more done. And if you haven't read these books, I highly recommend seeking them out, especially the Phoenix Project. It tells us a lot about why the world is the way it is. Along the same timeline, we went from physical boxes to, hey, we can make logical boxes inside the physical boxes. And with a hypervisor, we'll run multiple virtual machines inside of one larger machine. This is where we really shifted to this idea of working pets. Yes, you still had named mail server and things inside of like your Zeus or Olympus, but now it was running multiple machines inside of it. And you still cared for it, you still had to patch it, you still had to hand configure everything, but we're really working animals at that point, if we're keeping with my analogy. But then the cloud comes along because we realize we don't need to own the physical machines. We could just rent someone else's, which is all the cloud is, renting someone else's computer. And the way we built applications started to change because of that. We had multiple running services that were available all the time, so we could tie them together in interesting ways. And the way we handled security and authentication and authorization for humans just got passed along to these machine models. And yes, we did certain good things like certificate authorities in the best cases and SSH keys and very long strings called API keys. But this presented a whole other world of problems and challenges. Of course, along the way, we said, hey, we could just write down the configuration and don't need to manually configure these things. And now we just have this script we can run or this configuration file we can throw up against one of these projects. And now we can say, instead of one server, I need 48 servers. And it just magically happened, auto magically. Then containers came along. I know I'm mixing up the timeline slightly here, but stay with me. Containers let us chop those virtual machines into very smaller logical units where we just put enough resources to actually execute the application code. And of course, now we have the world of Kubernetes that came out of that and all of the wonderful security settings inside of it, which are very easy to understand and run. I jest, but if you're a developer in a hurry, what's the right answer to that question of set security run as non-root? This is truly the age of cattle when we've gotten here. Cattle, unlike pets, while we would like them to be alive, while we would like them to do what we want, they serve us. And we don't longer give them names like, Bob or Alice or Zeus or Teltran 3. We give them very long descriptors, very long paths that describe their workload inside of a zone, inside of an application. And what do you do with a sick cow? You put it out to pasture. You just redeploy another workload. You redeploy a new version of that thing. You don't need to hand configure it. You don't need to keep it alive. That's the pets to cattle part. But then agents showed up. Well, not yet. A few years ago, the technology got so good that we could do math very fast on very large pieces of hardware and do probabilistic guesswork, probabilistic generation with transformers. It's got many names, but we started calling these things generically by the companies that put them out. We started putting a name to these things. Now, remember that these aren't people. These are just processes that are doing probabilistic math using summations and very big equations that go very, very fast. I'll point you to one of my favorite talks on this if you would like to learn a little bit more about the math behind how AI actually works, called AI is Just Math. Get Over It from Ira Winkler. There's a link. You can just look it up from CornCon. He also did it at RSAC in 2025. But these probabilistic systems, we started saying, well, wait a minute. They don't need to just generate text. We could let them take actions as well. This is my representation of what that means. This is what an agent looks like in my brain. It is a GPT connected to the internet that can do all sorts of interesting things, like produce probabilistic systems, non-deterministic systems, do math equations, do all sorts of fun stuff. And we let it affect the real world. Like if it had its own wallet and passport and money, it can go out and do things if we grant it those things. Now, in all reality, that's not what an agent is. This is actually the architecture for an agent. And if you never looked at the architecture for how you build agentic systems, this should look familiar to you. This is just web application architecture. But that piece in the middle, that agent, is just a math machine that produces a probabilistic outcome by matching vectors and saying what vector comes next in the line based on probability. That's all it is. If you've never looked at the internals for agentic systems, they follow certain deterministic processes after they generate that probabilistic answer. OpenClaw hub and spoke architecture over on the left is actually a really neat achievement for the technology because it reroutes everything through the gateway, which gives us a very clean place to start putting deterministic checks. This isn't really a talk about that, but I just want to call out that if you're not thinking about deterministic checks inside of probabilistic systems and you're just worried about the outcome of the system after the fact and after it produces something, there's so many chances before it produces that outcome to get ahead of it, to see if it's doing the right thing. Now, there's something interesting because we anthropomorphized the workload and started calling it Claude or OpenAI or ChatGPT or whatever you call it, Cursor, that it, and our brains were like, well, wait a minute, that's like a person, but we shouldn't treat it like a person, really. We probably shouldn't give it full standing permissions because at the end of the day, that's what we really care about is access between all these systems. But to go back for a second, this evolution is all the same thing. It's an abstraction of the hardware. It's an abstraction of the operation. It's an abstraction. And that's all we keep doing is abstracting and abstracting and abstracting. AI is not anything brand new. It's just the next generation of automation. And that access that we give that automation, that's my day-to-day concern in security. Humans, we can give physical keys to, we can give passwords to, we can give access keys to. And if a human does something wrong, we can take it away. We can punish that person. We can fire them. If they do something really bad, we can take judicial action and put them in jail. But again, an AI, an agent is not a person. And we know that. We inherently know that. It's part of the moral quandaries we have around some of the usage. But I'm going to suggest if we shouldn't give an agent standing access the same way we give a human standing access, then we shouldn't also give standing access to any other abstraction inside of our IT ecosystem. I've been talking about this problem for a while, but passwords are very problematic. I'm going to say passwords and secrets interchangeably, but I mean API keys, I mean credentials, I mean certificates, I mean environment variables that contain a bunch of these things. I mean all of that when I say secrets. One thing we know at GitGuardian is these things leak. We publish a free report every year, and please go and download this. You do not need to sign up for anything. This is not a sales pitch. This is just go get your hands on this report. Every year we find that there are millions of secrets dumped onto the internet in plain text, specifically GitHub public. We look at every new commit that hits GitHub in public and say, hey, is there a secret here or not? If we do find a secret, we email the committer right then and there and say, hey, you've done this, probably not a good idea. And it's not just that people are putting secrets out there. If we find them to be valid, they stay valid for years. We recheck secrets from 2022, and 64% of the secrets we checked from 2022 came back as valid at the beginning of 2026. We're leaking at an exorbitant rate that's outpacing the growth of GitHub itself. This is the heart of the problem and why I'm passionate about this is we need to end this. And how we end this is the rest of this talk. So if you'll indulge me for the next 6 minutes or so, I'll walk you through what I think we can do moving forward. Now, one of my favorite books ever written is You Can't Teach a Kid to Ride a Bike at a Seminar. So some of the technologies I'm going to talk about today, I'm just going to send you down that path to go learn on your own. I'll point you to some resources, and you can always reach out to me, and I'm happy to talk about any of this stuff in depth, especially in person if we're ever at the same conference. But everything I'm about to talk about is based on the fact that there's an ID here. Now, this is from Wikimedia. This is not I photocopied this. This is a public domain image I found on Wikimedia. But it's an ID. It's a real ID. It's an ID that can verify against an authority, in this case, the state of Illinois. We can take that ID and start thinking about access from the point of view of like, can we prove you're you? Can we prove this workload is this workload? Can we prove this identity truly is this identity from a cryptographic proof standpoint? And if it is, we can also marry that with the idea of guest list, allow lists, to say, if you are this entity, you should be here because you're allowed to do these things and these things only. And instead of standing privilege, where you get a key and anybody can pick it up and use it and do a wide variety of things because you over permission keys so the machine can just keep going, you can narrowly scope the access in a very straightforward manner based on we know this identity is real and we configured the access patterns to allow that identity to do these things. It's simpler than you think because there's technologies that allow you to do this. And again, I'm not going to go into depth on these. I'm just going to touch on these very lightly and send you down a road of thinking about these. That's my goal today. First, I'm going to start out as foundational. It's called SPIFFE, Secure Production Identity Framework for Everyone. It's one of my favorite projects out of the CNCF. It's been around for about 8 years now, and it's open source. It's free. And by the end of this, I promise I will point you to a case study of a very large company that is using this at scale in an amazing way. But Spire is its free open source runtime. And the basic idea is when any workload is born, you simply supply it with identity over an API through a certificate. That certificate contains an SVID, a SPIFFE verifiable ID, that it can take to any other boundary. And at the boundary, it can verify that, hey, this thing is that thing. This workload is truly that workload. Once we verify that, then, hey, is this supposed to be here? Is this allowed to be here? And then you issue a workload identity token, or a workload token, or a work token, I should say, just when the transaction needs to happen. There's no standing privilege, nothing standing except the identity. There's a great book about this. I highly recommend everyone on this call read. spiffy.io/book. It's 198 pages, but it will change your life. In fact, this core idea of verifiable ID over time that can be exchanged for work is baked into Kubernetes itself and has been for over a year. I'm not going to get into the details, but if you have not talked to your teams that are building with Kubernetes about this and you work in security, I highly recommend having that conversation. Go talk to your head of development, ask them about workload identity and Kubernetes, and you can start having this conversation. Now, to use Spiffy effectively at scale does require some code changes unless you implement it through Istio. Istio is another project from Cloud Native folks, and it intercepts all of the ingress and egress out of the pods, out of any Kubernetes pod. And that can do some interesting things because if we control the traffic and the in and out, then we can abstract that layer of identity and configuration around authentication and authorization into a control plane. And that's what Istio provides. Envoy is the proxy that actually allows the communication. And they've actually done some updates fairly recently with Istio Ambient. Uses zTunnel very efficiently. But again, I'm not going to get into the details here because I don't have a lot of time. And you might be thinking, oh, that's great, but I don't run 100% cloud native. I live in a world with a lot of legacy. Guess what? This standard is coming. I'm not going to go into great detail, but we're on draft 5 of this right now from the Internet Engineering Task Force. But WMSI, the workload identity in a multi-system environment, is spiffy applied to everything in the universe. The same way that TCP, IP, HTTP are standards, this standard is coming. But you don't have to wait for the IETF to sign off on it because it's already here. It's already been implemented. This idea of workload identity federation at scale has already been implemented by the major platforms, all of them. The one I'm going to point out and to go research, I would suggest everyone here, even if you're not an AWS user, because I really just personally like the way they wrote about it and the way they talk about it in their videos, is AWS Security Token Service, STS, can now be federated across services. Not just internally to AWS, but that AWS STS token can now be taken to any other service that accepts OIDC. And I know that's a little technical. If you're not familiar with that concept, the boundary can be another entire service provider like Databricks or Azure. You can go to Azure with a workload from AWS, from any service they manage, and say, hey, I am here. I need to do this work. And because of the way that the certificate works that they're holding, they can do a handshake with the certificate authority to say, yes, you are you. Let's see if you're on the list and what I should grant you because you are on the list. I'm not going to get into the details here because I don't have time today, but it's very straightforward. And the main reason I want to show you this picture is it's free. And that's the point. If you don't want to go down a path of let's build it ourselves, if you don't want to go down the path of hand configuring it, there are companies that will help you out. I'm leaving many off this list, but there are many people working on this problem out there. As I wrap up, I'd just like to remind you that ChatGPT with a wallet and keys is a bad idea. But ChatGPT with a wallet with an ID in it is a good idea. And if we shouldn't give our agents, these probabilistic systems that have access to the real world, standing privilege, we probably shouldn't have given access to any of our other workloads. I promised a case study. I wasn't involved in this. It's just one of my favorite pieces of writing I have seen in 2026, solving the identity crisis for AI agents. Uber is the company that put this out. You can go read how their team is literally building this because the immediate feedback you might hear from people is like, yeah, but you're introducing so much overhead with workload identity instead of passwords. And they proved you don't. They proved it's all acceptable at the scale that Uber runs. And if it's acceptable at their scale for their SLOs, it'll be acceptable for your team. And it will save everyone a lot of time and everyone a lot of money and everyone a lot of headache because it's ultimately a much more secure way to handle AI. We're at this golden moment. Let's use it. Let's use it to apply workload identity to all of our non-human identities across all of our infrastructure. Because again, we're just dealing with abstractions of abstractions of abstractions. But now we've given it a name. Let's use the power of anthropomorphification to improve the security for all of our systems. Thank you so much for your time today. Again, I'm Dwayne. Please find me online. Write to me at dwayne.mcdaniel@getguardian.com, and I'm happy to answer any questions.